In this example problem, we are supposed to use a graphing calculator, but let us see the method how it is done more than completing this problem, because many of you do not use graphing calculators. So let's see how it is usually done. Let's see what are the methods and the steps involved, and let's see what is the main concept behind this problem. The table shows US backpack sales in millions of dollars according to the Travel Goods Association. Make a scatter plot and a curve of best fit to show the trend over time. Then determine the backpack sales in 2015. So we have a table which shows all the sales in millions of dollars for every year from 2000 till until 2014. But 2015 is not there. We are supposed to estimate it. So now for the solution, basically if you want to get a graph, you can directly enter it in the graphing calculator, and then you can use the scatter plot list and you will get this graph. If you even plot this accordingly, see, the thing is you should not plot from 2000, like consider this as 0. Okay, 2000 is 0, 10 1 is 2001, and so on. Then plot it accordingly with the proper scale. You will get the graph. Now, once you have the graph over here, now determine the polynomial function of best fit. This is basically done in the graphing calculator itself. Over here, this will, based on this graph, it will tell you which is the graph, what is the function of the graph that will fit in this. So in manually, it is not possible. You need technology for this. That's why it is technology to model. Now, what happens is x to the power 4, that is a quartic function. X to the power 4 is called quartic. X to the power 3 is cubic. X to the power 1 is linear, and so on. So this is quartic. X to the power 4. These coefficients will be given from the graphing calculator. You can see over here, this is the thing. Now, graph and evaluate regression function. Now basically for x is equal to 15, you're interpolating. So they are asked us till 2000, they have given the values till 2014. They're asking you to estimate what is next. So the interpolation will be done from the calculator itself. If you extend the graph, see, it's going like this. If you extend it, you'll get an approximate answer. The answer for X15, that is 2015, is 3.523 billion. Let me just go back quickly over here. See, it was 2255 for 2013, 2014 2779, 2015 it was 315 and something. That is approximately correct. So, sorry, over here 3.523. Yes, that is approximately correct answer. Similarly, let's do one more problem. This is about finding the average rate. This is important because there are various methods to find the average rate. We will see one by one. The RSV rocket was designed to carry as much as, I'm sorry, this typo error, as much as 75 tons of supplies and 4 astronauts to the moon and possibly even to Mars. The table shows the expected G-force on the rocket over the course of 200 seconds launch. So now we have the times are given and the acceleration, that is G-force, is also given. And we have to find the average rate of change. Okay, and we need to interpret these results. This result. So now first thing is optional to graph. Okay, you can graph this because we'll understand how the graph is. Now it is not compulsory to graph this. You can even find the average rate of change just by the values over here. But by graphing, let's just double check it. Now, when you graph it, you will get this. See, from 0, it is 1.34, to 20, it is 1.26, and so on. You will get this points. Now, rate of change is always dy by dx. What is dy? Difference in y. See, sorry, it's somewhere over here. What is this distance dy? If you see, it will be somewhere over here. This is 1 is 0.5 and 0.5 nearly to 1, but if you look closely, it is about 0.9. Okay, the distance over here from year to year, it is about 0.9, near to 1. And what is dx? Dx is from here to here. This is 200. Very simple. So you just divide dy by dx. That is the rate of change, the slope. So it's 0.9 divided by 200. This is your answer. But if you want to find algebraically, you need to find, see, they have told over the course of 200 seconds launch. So the final function is 200. So this is the formula, f of x2 minus f of x1 divided by x2 minus x1. This was there in the last term. We had even the problems for the final exam. In the exam scheme, we had this problem. So remember, f of x2 minus f of x1, initial value, last and initial. That is f of 200, function value of 200 minus function of 0 divided by 200 minus 0. It's, if you might remember this, y2 minus y1 divided by x2 minus x1. This is it. Now, what is the y2 value? It's 2.2 minus y1, 1.34. X and y, isn't it? So, divided by x2 is 200 minus 0. Now, you will get 0.0043. It's almost similar. So, interpret the results. From 0 to 200 seconds, the average rate of change acceleration was increase. Okay, why? You can see over it's increasing, is it? Okay, though it's decreasing over here, from this to this, the value is positive. If it was minus, then it would be reducing, but it's positive, so it was an increase of 0.043 g-force gs per second. So this is the average rate of change problem. Graphing is optional, but it's better to graph. You'll understand, but it's all depending on the time. If they have not asked it, if they just ask these two, just solve it directly. Okay, so that's about the second lesson. It is again a simple lesson. It's about graphing, more into graphing. So you need to be quick with the table of values, and then after table of values, just graphing. So try your best, go through the videos again. If you have any doubts and if you have any questions, you can always leave it in the comment section, and I'll try to get back to you as soon as possible.